Okay, so I have two companies now. I have company X and company Y. Every year, 20% of customers of company X move to company Y. That means that zero point 0.2 of company X go to company Y. And 0.1% of the company Y go to company X. Este, so that means that 80% of company X stay here and 90% of company Y stays here. Um, Remember the transition matrix? Here is where I put the from, and here is where I put the to, because I want columns to add up to one, no? So let us do xy. So this would be zero point 0.8, because if I start from x and I end up with x with a probability of 80%, if I start in x, if I start with x and go to y, I will do that with a 20% probability. If I start in y and go to x, that is a zero point 0.1 probability. And if I start in y and go to y, that is a 90% probability. So this is my transition matrix. Now, problem problem two is very long. Now it has 4 marks. So remember that to find we first need to find the eigenvalues and then the eigenvectors. To find the eigenvalues, remember that we have in our formula booklet the characteristic polynomial, that is the determinant of a minus lambda I equal to 0. In this case, it is the determinant of a 0.8, 0.2, 0.1, 0.9 minus lambda 1001 equal to 0. So that is the determinant of 0.8 minus lambda, 0.1, 0.2, 0.9 minus lambda equal to 0. And now I use the formula for the determinant, and that is 0.8 minus I. 0.8 minus lambda times 0.9 minus lambda minus 0.2 times 0.1. This is the formula for the determinant, no? And now I want to solve this equation. And because we always have access to a calculator, let me show you how I'm going to solve it. I'm going to go and add a page that it's going to be a graph. And what am I going to graph? I am going to graph this expression, no? It is a quadratic expression, so it's going to be very, very easy to graph. So instead of writing lambda, I'm going to write x. Okay, and now I want to find the zeros. I want to find the intersections. Those are going to be my eigenvalues. So I go to menu. Let me do some zoom. No, I'm gonna do a zoom box. Oof. Okay, and now I want to find, if I want to graph this label that I don't like, remember that I can do control and the hand. Let me just escape from this. I'm gonna do control and the hand to move the label. I'm sorry, I just grab it. No, and now I'm gonna analyze to find the zeros. No, I'm gonna do it twice. So I have two zeros. I have two eigenvalues. One eigenvalue is 0.7 and the other eigenvalue is 1. Um, so my two eigenvalues are 0.7 and 1. Okay, Now we need to find the eigenvectors. To find the eigenvectors, remember that I want to try to solve for each different eigenvalue, like the equation a times x equals 0.7x. In this case, I want to solve 0.8, 0.2, 0.1, 0.9, xy equals 0.7x, 0.7y. And remember that from here, I can find I can have a system of equations that would be in terms of, let me do it. Okay, let me go back to my calculator, and I'm gonna do this the exact same as I did here. So now it is 0.8x, 0.1y equals to 0.7x, 0.2x, 0.9y equals to 0.7. So look, in this case, I have like negative c2 comma c2. If I just replace it by a 1, it is a 2. Observe that now it is a 2 because it is the second time that I've done this, no? So my eigenvector, my associated eigenvector would be negative 1, 1. So this is the eigenvector associated with 0.7. And now let us do the same for this is the eigenvector. This is the eigenvector. The eigenvector with eigenvalue 0.7. And now for the other eigenvalue, lambda equals 1, I do the same. Now I want to find the vector such that it is, so it is 0.8, 0.2, 0.1, 0.9, xy, and this is equal to xy. So I set a system of linear equations. I do exactly the same. I'm just going to copy these, but now instead of putting a 0.7, now it is just a 1, no? So it is, my answer is 0.5c3, comma c3. If I plug in a 1, this vector becomes, by plugging c3 equals to 1, this is a 0.5, comma 1. Let me double check that they are not asking me the eigenvectors in any particular way. So this is a fantastic eigenvector. Great. Now, they are asking me to find the matrix P and the matrix D such that this happens. And remember, the matrix P is as easy as the matrix that has the eigenvectors. So P is going to be the negative 1, 1, 0.5, 1. And D, because I put this one first, I'm going to put this eigenvalue first. 0.7. And now because I put this one second, I'm going to put this eigenvalue second. Okay, so this is a diagonal matrix, and this is the change of basis matrix. Okay, now, so we're going to explore a little bit more about this way of writing the matrix. First of all, we already know what is P and what is D. And what are we missing? Well, we're missing a P inverse. What do we do to find P inverse? We go to menu, matrix and vector, and we go to, remember this option that help us find the inverse of a matrix. So menu, matrix, reduce row echelon form. And in here, I'm going to create a matrix. But this matrix, remember that this time it won't be a 2 by 2. It's going to be a 2 by 4 inside of the row reduced row echelon form. In here, I'm going to write the matrix P, and then I'm going to write the identity matrix. So the matrix P for us is negative 1, 1, eh, 0.51. And here, I write the identity matrix. So observe how the identity matrix was here, and now it's here. And so if here is matrix T, here is the inverse. Sorry, if here is matrix P, here is the inverse of P. O sea, this means that P inverse is the matrix negative 0.7, negative 0.6, 0.6, 0.3, 0.6. What are they asking me in this question? They are asking me for an expression for company X after n years. So here it is an expression. It is not just like a value. So here they are not just asking for the steady state. Here they are actually asking for a mathematical formula, no? And so how do we get this formula? Look, we're gonna use the fact that, o sea, we want to find an expression for what is t to the n. O sea, t to the n is t times t times t times t. O sea, this is the same as the original matrix that was 0.8, 0.2, 0.1, 0.9 to the n. So what we know now, o sea, instead of finding this expression, we already know that t is the same as p d p inverse, no? Where D is a diagonal matrix. This is the matrix of eigenvectors, and this is the inverse of P, no? So to find an expression for Tn, we're going to do this. Observe the following. So what is Tn? Tn is the same as P, the P inverse to the n. O sea, and do you agree with me that this is the same as P, the P inverse times P, the P inverse times P, the P inverse, n times, no? Okay, and look, something marvelous happens. Because here I am multiplying P inverse with P. And here I am multiplying P inverse with P. And here I am multiplying P inverse with P. And here I am multiplying P inverse with P. So the only things that survive are actually the D's. And the first P and the last P. So an expression for Tn is the same as P, d to the n, P inverse. So this is the same as the matrix of eigenvectors that we already have. What is it? Negative 1, negative 1, 1, 0.51. The matrix of eigenvalues, which is 0.7 to the power of n. And this other matrix, negative 0.6, 0.6, 0.3, 0.6. O sea, this multiplication, this is a bit, o sea, you can be asking me like, hey, Mr. Quechua, I feel that this is too complicated. O sea, if I am just trying to find this. But actually, it is way easier in the case that you do not have a calculator, no? O sea, like, the reason why we do this is for historical reasons. Because there was a time in which you were not able to do matrix multiplications in an efficient way. And the most efficient way of doing it was by este, doing a diagonal decomposition. So what is this? Eh, so now we need to do the multiplication of these three matrices, and the decomposition of these three matrices. And because here is by both companies have a 1,200 customers, is actually a 1,200. This is what I want to find. No, I need to find this multiplication. I am gonna ask for this. Yes, I know you. I know you. I am gonna ask for this. And so what do you have to do now? You actually have to do the multiplication by hand. O sea, just observe that this is the same. Bueno, 1 to the n is 1. And times 1,200, no? Okay, so for example, to do this multiplication, this part of the multiplication is quite easy. We can just put it into the calculator. Um, and so I'm just gonna go to menu, matrix, create a matrix, a 2 by 2, that is gonna be, well, but positive. Okay, times menu 7 1 matrix. Now number of rows, 2 rows but 1 column. Okay, let us round it because the problem here, o sea, why am I rounding here? Because I am not putting all the decimals of 6667. So this part of the multiplication is, let's say, 400 and 1600. Okay, and now let us do this part of the multiplication. Okay, now we need to do this part of the multiplication, no? So to do this part of the multiplication, hay que estos 0 and 1, no? So we actually need to do, like this is a matrix multiplication, this times this. So that is negative 0.7 to the power of n. O sea, I did that by multiplying this times this. Then I'm gonna go, I don't know, that is 0.5 because I multiplied this times this. Then I go this, that is 0.7 to the power of n because I am doing this times this. And then 1. Then I need to multiply both these two operations together. No, look, the first this second part, I cannot do it in the calculator because it is like a symbolic expression. So now I need to do negative 400 times 0.7 to the power of n plus 800 because I did this times this and this times this, o sea, that is 400 times 0.7 to the power of n plus 1600. They are asking me for a steady state expression for x. So my expression is this part. My expression, the expression that they are looking for, is this one. So they are just not asking me for like the steady state, but they are asking me for how is the steady state going to change in terms of n, no, which is quite important and interesting. Eh, okay, now finally they are asking me for what happens when n goes to infinity. So, o sea, like, eh, o sea, now they could be asking me for the steady state. O sea, what happens? Eh, o sea, two ways of seeing this question. One way is like, yes, so grab your original matrix, the zero point 0.8, 0.2, 0.1, 0.9, and do it to a power of 50. If we do that, I think that we all know what to expect, no? Let me grab this one, copy it, my matrix, 0.8, 0.2, 0.1, 0.9 to the power of 50, and then let us multiply it by this amount of customers, which is 800, no? O sea, like my steady state goes to 800. O sea, another way, o sea, if I multiply this by 1200, I can see that I will have 800 and 1600. The difference between this answer and this answer is that in here they are just asking me for the number. O sea, my answer is 800, no? Which is quite easy. Here they are asking me for an expression, but don't worry, we will practice this and do it many times so that you can know how to find that expression. Another way of solving this last question is if you observe the expression, o sea, observe that your expression is negative 400 times 0.7n plus 800, and observe where does this go, where does this expression go as n goes to infinity. So this part goes to 0, no? And 0 times 400, that is 0, so this goes to 800. Both way of seeing it is great.